Welcome to Physics for Good. I'm Allison Bowley, and today I want to talk about standing waves. Now, in my opinion, the easiest and most fun way to relate to standing waves is through music. This is my friend Kim creating a standing wave. Now, the reason it's called a standing wave is actually pretty simple. If you look at it, you can see that the crest appears to stand in place. But how does it get this shape? So this black line represents a guitar string that has not been plucked. And we know both ends of a guitar string are tied down or fixed, and therefore we can consider them boundaries. Now let's say we pluck the guitar string and we produce a wave like this blue one right here. Well, we know when a wave reaches a boundary and bounces back, that's reflection. Well, what you're going to find is if you do this, if you send a wave down and reflect it off of a fixed point, what happens is the reflection actually comes back the opposite way, like this red dashed line. And so that's how the wave gets this shape. Now, the other thing that generates this shape is still the endpoints, but this time we want to look at what is the amplitude at these endpoints. Well, because they are tied down, the amplitude of the wave at these two endpoints of the guitar string must be 0. You cannot have any amplitude here because they're tied down. And so I've cheated a little bit. I wanted to draw it this way because this is the way we're familiar with seeing an entire wavelength. But what actually happens mostly, the primary wave that's generated, is this one over here. It's basically this part of the wave, right? We can see there's 0 amplitude here and there's also 0 amplitude here. And so that's what I'm drawing. That's what I've drawn over here. And so this is called, in fact, the fundamental wavelength, or the first harmonic. The one that I drew over here, because it's easier to visualize, is actually the second harmonic, or the first overtone. And now you can see we're getting into some musical terms, overtone, harmonic, these kinds of things. And so what happens then when on a shorter string, or when you put your finger down over a fret on a guitar string? What you're doing is you're shortening the length of the string. So now we come down here. You're shortening the length of the string, but we still have to have 0 amplitude at both endpoints, and so you've shortened also the length of the wave. Now, I didn't mean to make the amplitude shorter also. That's a function of my poor drawing skills, not of the physics. And so if we were to draw the first overtone, we could see also you have shortened the wavelength. And again, I did not mean to shorten the amplitude. But you can see the wavelength is shorter, and what does a shorter wavelength correspond to in sound? It corresponds to a higher pitch. And so that's why when you move to a shorter string, or you put your finger down over a fret, you get a higher pitched note. You can try this out for yourself if you stretch a rubber band into 3 unequal segments. Sure enough, as the length gets shorter, the pitch gets higher. Standing waves are produced on a drum head too, but they're a bit too complicated for this video. Nevertheless, it does bring me to my annual benefit concert, Drums for Toilets. Why toilets, you ask? 3 reasons. Number 1, diarrheal diseases are the number 2 leading cause of death for children worldwide. Number 2, if we want girls to stay in school when they hit puberty, we must provide them proper facilities. And the 3rd reason is that some women without a safe toilet to use get assaulted when they go out into the fields. And so I will drum for toilets. The first concert was also on the very first World Toilet Day, November 19th, 2013, and every year has raised money to build latrines in Africa. At the time of this recording, I'm finishing up my dissertation, and so I decided to combine this year's Drums for Toilets with my graduation party, asking for donations in lieu of gifts. We played songs that have been meaningful to me in grad school and ended with a drum solo I wrote that I'd like to share with you called Everything's Better with Kim. As usual, because this is Physics for Good, 50% of the ad revenue generated from this episode will go to the latrines funded by Drums for Toilets. If you want to support Drums for Toilets beyond just watching this video, go to AllisonBoley.com/drumsfortoilets, and whatever year you're looking it up, that will redirect you to the fundraising page from the nonprofit that we are using that year. You can also stream or purchase a vocals and percussion-only version of O Come Come Emmanuel wherever you get your music, and 100% of the profits that come to us will get donated through that year's Drums for Toilets. Thanks for watching. If you like what you just saw, please consider subscribing right here and sharing the video with a friend. Also, check out the video description where you'll find a link to the charity you just saw, as well as some affiliate links.